Okay, this is ITS128, and it is November 12th. And let me share my screen. And so we are right here. We're in strings. We're actually going to start strings today. We might get close to finishing. No, I don't think we will, but it's actually a pretty short chapter, and we kind of know a lot of it already. So we might get all the way through. So let's get right to it. So strings, we already know that when we input a string somehow, we've been inputting them, that we can refer to the characters, refer to the substring by doing something like this. And so, we can index each character in the string. And all this chapter does is talk about all the fancy, clever ways that you can manipulate strings. And it turns out that this is a really powerful, rich set of functions that are built into a language, Python, because a lot of stuff that you do is slicing up strings. If you want to parse information off of a web page, you're actually parsing through HTML. And so you want to be able to figure out how to slice out stuff, slice out the information that you need. So anyway, all those functions are here. First it talks about slicing a string, where you put a start and an end, and it just returns to you that portion. Let me open my chat just in case somebody wants to talk to me. So here, for example, my string is this whole string here, which is "do not lie" with an exclamation point at the end, couple of spaces in between. And if we just want to get characters 0 through 2, you remember when we refer to a substring or to endpoints like this in Python, we include the first digit, but we go all the way up to, but not include the second digit. So this here is really referring to index 0 and index 1, and not index 2. So that's why this is actually just the first character 0 and character 1. And this is character 0 through character 5, through it, and including character 5, not character 6. So you see, that's why it's just like, it's this. And then here's 7 through 10. It starts with 7, so it's 7, 8, and 9. So it's 7, 8, and 9, and it does not include the exclamation point. Okay, that's pretty important to remember. So here, this is a nice participation activity that lets you fiddle around with substrings, and we can go like, if we start at 0, we get the whole thing. If we leave them both blank, we get the whole thing. So anyway, here, up here, let's see, somewhere around here, I pointed out that that you're actually creating a new string when you do these creating a new object rather than modifying an existing object, because it's actually immutable. But that to me is not very important. Sometimes I wonder why we stress that so much in Python, but it does help you understand it better. Okay, so here's some other ways of slicing. Okay, this is obviously 10 through 18. And this, though, is 10 up through 5 characters short of the end. So if this string is I guess, 32 characters long. Does it say? Anyway, it's however long this is. This is missing the last 5 characters. From 10 all the way up to the 5th character back. So, 1, 2, 3, 4, 5. I guess this one, the capital N. All right. This is somebody just asked indices. You all saw that. Indices is just indexes. It's the same word, but it's a different way of saying it. So the indexes of a string are these things. What I'm talking about here. Okay, so this starts at index number 8, which would be 1, 2. If I go this one. 0, 1, 2, 3, 4, 5, 6, 7, 8. So this starts at 8 and goes all the way to the end. See, so if you leave the second index off, then it means all the way to the end. If you leave the first index off, that means starting from the beginning. And so here, for example, we start from the beginning and we go all the way up to all but the last character. Yeah. So anyway, so these are more complicated way of slicing. And then there's this thing called the stride. There's actually a third parameter which defaults to 1, but when you give a boundary like in this case, you're going from 0 to 9 up to and including 9, but not 10, and you're skipping every other one. See, so that's a way of and so here let's I like to take this and let's put it inside here, and it's my test.py on my desktop. And so if we run this, I'm on my desktop, py test.py. So these are all the numbers from 0 through 9. And then the first thing it does is it displays out all the numbers, and this is how you can say that. It's because it's all defaulted. The first one is starting at 0, the second one is at the end, all the way to the end, and the third one defaults to 1. So that's pacing it through stride one at a time. Here it's 2 at a time, so that's why you get the 0, the 2, the 4, the 6, and the 8. It's like every other one because you're going 2 at a time. Here it looks like you're going 3 at a time, 3 at a time, but 8 is the highest one. So, between 1 and 8, because it starts at 1, ends at 8. So that's why you put 9, and it's every third one. So that would be, 1, 2, 3, 4, 5, 6, 7, and then that's it. So that's why you get 1, 4, 7. So it's interesting though, if we go, we can go backwards through the list by making this a -1. Okay, so the stride is not 1 at a time from left to right. It's 1 at a time from right to left. So this should make it reversed. So if we save this and run it again, see, we get, this is all numbers, and this is the last one, and it's in reverse order. Okay. So anyway, that'll become relevant with one of the labs. Okay, so so that's the stride. Very interesting. There's nothing like that in any other language that I know of. Although sometimes something like that, when there's such a good feature that pops up in one language, something like this would be easy enough to add to a language. So it could be that other uh, languages do that now in in later versions. Okay, so here's a challenge activity where you're supposed to be you give a start index and an ending index, and somehow you put the colon thingy here, the something colon something here to extract out that. Okay, so all right, so it's when you put 4 and then 7, this was this was 4 through, was 4, 5, and 6. So let's see, it's 0, 1, 2, 3, 4, 5, 6. So that would be 4, comma 7. So I think all it is it would be this and this, because this would be 4 and this would be 7, and you end up with just 4, 5, and 6. So that's just something like start index colon end index, I think. Okay, and so then that ends up being that. And oh yes, okay, all right. 814 is jumped. Great. All right. So now that's a basic slicing. This is an advanced formatting. So this is for when you're printing out strings. And what you can do is you can add padding to each side of the string that you're printing out. If you want to make it so the string is always going to be a specific length. And why would you do that? Because if you're printing out a table and you're using a monospace font and you want to make something that looks like a table, then you want to be able to do something like this, kind of easily. Okay. And so if you're printing out, like here's an example. You create a format string that looks like this, where the name field is going to always be 16 spaces, and the goals field is always going to be 8 spaces. Then when you actually execute it like this, it's going to, the first name is this, it's this string here, and goals is this string here. And you notice the way it works is because you made name 16, then this takes 16, and so it pads the right-hand side with spaces up to 16 characters. And then it does the same thing for goals here. So so that's one way of field width, but there's also you can do like left justified or right justified or centered. Okay, so there's this aligning text character here, which okay, like this. So here you would want the two words to be all the way to the left, starting at the very beginning of its allocated 16 spaces or 8 spaces. In this case, for right align, you want it all the way over to the right. Okay, so you see this is the difference here. And then you can do an upward arrow, a caret or whatever you want to call it, meaning you want it centered. And so you see in this case, the player name, it's going to be an equal number of padding characters on each side, so the thing looks like it's centered. So that makes it so you can make things look all lined up better. So this just is however much it takes. This is going to take 4, and the default must be to pad to the left. Pad on the left side because it's a number. Fill character. It's an empty space. So anyway, so this looks like that. This looks like that. And this is where it's centered, you see. Here it's centered, and the fill character is not a space, it's a 0, so it's going to look like that, because really you're centering the 18 and you're putting the fill characters on each side, and here you're overriding the space as a fill character. You're actually saying it's a 0. All right, so that's formatting, fancy advanced string formatting. I guess here you can do, when you're doing precision, okay, so it's this thing here. So this says it's a floating point number, 2 digits to the right of the decimal point. So you're displaying out this variable pi, calculated. Oh, it's and you're using this way of doing format where in this part you put what pi is, and here it's this value, and so that's what that is there. Then this is the format, and it's so anyway. This is unique to this language. Here, print 1 decimal point followed by a C. You want it to print like that? Gee, I don't even know. 1 decimal point. What? Oh, am I supposed to put something in here? Oh, never mind. 0. 5.0? Oh, x equals 5. Never mind. Okay, so that does 1 decimal point. So I think it's something like this. Print air x equals air temperature. Oh, got to print out the C. Do this maybe. Yeah. Okay. All right. Okay. Anyway, what's next? String methods. Yeah, the curly braces is not for the padding. The curly braces is for the formatting. So that's a good question here. Let me go back. So like, oh, you mean like, oh, yeah, you might say that. Both here we're saying this is kind of like a field or something. Format string here is it takes care of 2 variables, or two parameters. something called that you can refer to as name and something you can refer to as goals. So here we're going to use this format string, and we're going to say that name is equal to that and goals is equal to that, and then that, because it's this and that's this, then this value gets plugged into there, and this value gets plugged into there. And then the 8 means it's going to take up 8 spaces, and so this is only 2 spaces, so it's going to pad with 6 more spaces on the right side. And this is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to pad 6 more spaces on the right. Is that what it does? Well, yeah, I guess 1, 2, 3, 4, 5, 6. Yes, okay, and then 8. But
I have a question.
Yes,
So for the numbers 22 and 7 over there, how do you define that to the right?
It's because of this. This is the same as this, and so it's actually you're using this. And here, and this is simply saying goals is equal to 22, and that's this. So this is equal to 22. And here you're saying name is equal to here. Let's I'm going to copy this and see what this looks like. Copy. I'm going to see what this looks like here. Okay, so I'm just gonna.
Yeah, I was wondering how the curly braces define the term within the printing format. Like what placement? If it's only one printing format string.
Okay. Let me just let me first see if this works. What does this give me? Okay, yeah, okay, good. It gives me that. Okay, that's what it should give me. So now, I can put anything here, blah, and I can do something here, and something else or whatever. And now my format string is different. It's always going to have this here. This is the thing. This says, okay, this is like a placeholder. It's a placeholder for something called name, and it can be 16, and it's going to be 16 characters long at least. And so so when this is used, then you can define name, and the way you define it is inside the parentheses here. So when this runs,
Okay, yeah. I get it. Thank you.
See, I got this blah here. Yeah, something. Yeah. So that's it, and that's you actually see this. I mean, you see that in other of these template replacement kind of languages. So anyway, kind of interesting that they have actually incorporated. To me, it's interesting that I guess Python's been around since the 90s, and so when I'm learning new languages, like languages to do mobile applications, that's you're learning about languages that are based in the browser. The browser is what's executing that language, and you see a lot of this where you have a curly braces and then something in there that's actually replaced, and this is probably where they got it from. So anyway, all right. Yes. That's a good question, and I'm gonna have to remember that, emphasize that later. Yes.
No, but just to continue. See, how do you get 20? Like, okay, for the 22 for the 2 all the way on the right, how do you get it to print at position 24, and then the second 2 to print at position 23? Do you
Yeah, yeah. Let me expand on that. Okay, so it actually was this. Let's go back and see if this is exactly what it was, and yeah, okay, all right, so okay, so um, the reason it prints where this one is sort of left justified, because that's the default. And the reason it prints here, this is right justified, because that must be the default for numbers. We can mess with that. Okay, so I'm gonna do, and just let me to make sure I get this right. Where are those format? Yeah, here. Okay, so yeah, here we can, okay, so left justified. Okay. Um, so if I make it be left, this left justified, if this is left justified and this is left justified, this one's not going to change because that's the same as the default, but this one will change because the default is right justified. And let's see that is what happened.
Okay, that makes a lot of sense. Thank you.
Yeah. Okay, now, so you can also make it center. Yeah, center. So that's this upward arrow thing. Maybe the best thing to do is make this one centered. Oh, wait a minute. Let me see. It's left. Okay. Right. Now you'd wanna. Yeah. Anyway, yes. I guess this one's centered is a good way to do it. So that's kind of up and down like that. But then if it's, yeah. Anyway, yeah, people spend a lot of time on this kind of stuff. What's the best one? Um, this is the best one. This should be, okay, this is the default, so it doesn't matter. This can stay the default. This, this is going to be the default, but having it be 6. How about 6? And this can be center 8, format 2. So I want this to be format 2, and this to be format. Okay, so I'm just going to make 2 different formats. Oh, no. I guess I want this to be 8. No, I want that to be 8. Oh, center. Oh, I see what I did wrong. Okay, make this like 10. Well, it's 12. Why is this pushed over? Oh well. Anyway, you can spend hours on that kind of thing. All right, so that's that, and this 346. Okay, don't want to get carried away. Okay, here we're messing around with the point number of digits to the right of the decimal point. That's what we did before. And string methods. Okay, so there's some methods that go along with strings too that makes things real easy. And so the way you do it is you have the string here, and then dot, and then the method name, and then any arguments that go to the method. And so here's an example of how to use this replace method. And basically it's you replace all instances of this particular string with this particular string with new. You can also limit it to a maximum number. So here's a dumb example where you have this phrase, one day I will have 3 goats, 6 horses, and 9 llamas. And you're going to change it to Spanish by just changing the numbers. And so you just have, and so you write this program so it can go from 1 to 9. And, it only uses the 3 and the 6 and the 9. It doesn't use any of the other ones. The point here is that this is different than that. So in other words, it's case sensitive. And so, you can run this, as this thing executes, you can see this phrase down here changes. So there made 3, 4, 5, and now it changed to 6, and then it changes 9, and then prints it out. So that's the replace. So that actually does something to the string and returns another string. So that it's going to return another string that's different. This is the find is basically to find the index of the first occurrence of something, a string usually. And so this is going to return an integer, because it's going to be an index number, 0 through is however long the string could possibly be in this case. So here's an example. Let's say you got this string boo-hoo with an exclamation point at the end. If you're looking for the exclamation point, it's going to return a 7 because it's the 7th, 0, 1, 2, 3, 4, 5, 7th index number 7. Boo is index number 0 because it's BOO is starting right at the 0th one, and OO is going to be starting right at the 2nd one, and so that's why it returns a 1. Here, you're giving it a second argument, which is where to start from. And so you might not want to start right at the beginning. You might want to start after a certain point. And we use this a lot when we're parsing, like we're going along and we're parsing a document, and once we're done with a certain part, we want to start from then on and continue forward. And so start is used a lot. And then there can be a third argument, which is when to stop. And you can do a search from right to left, as opposed to left to right, and that's R find. Starts with an R, starts to the right. Reverse string. You can also count the number of times X appears in the string. So in this example, and that's count. So in this example, because you're looking for how many times OO appears, and there's 1 there, and there's 1 there. That's 2 times. So that's why it's going to return 2. And then in is like, it's returning if count is greater than 0, okay, but it just returns true or false. Okay, so in other words, if this string is inside of this string, then it's going to be then this is going to be true. This is an expression. It's going to be true. This is the in operator. This is a hangman example where you get like 10 times to guess, however many times to guess all the letters of a word, and if you're able to guess the word, then all the letters, then you win. Otherwise, you lose, I guess, or something. All right. This talks about string comparisons, and so this is to see if something, the result of all these are going to be true. It's going to be true or false, and so you use this for an if statement or for a while statement So this is true. These strings are exactly the same, and so you use the double equal. This is not true because this string is different than this string. That's obviously, so that's why it's false. This string is bigger than this string because you start with the first character on the left. Y is bigger than A. Capital Y is a bigger ASCII value number than capital A. Okay, capital A is like, say, ASCII numbers, ASCII numbers. Wherever. So capital A is right here, and that's a decimal 65. And capital Y is down here, which is a decimal 89. So 89 is bigger than 65, so that's why that. And so for this, it's again, it's from left to right. It's all the way to here. This is the same as that, all the way to that. So what's next? It's the capital S and the capital Z. Is this greater than this? No, it's less than, because S is less than Z. It's the first one where it's different. So that's why this expression is false, because it's not true.
I have a question.
Yes.
I don't know how to pronounce it. ASCII value, is that a universal code?
Yes. Yes, it's
that's universal for all programming code?
Yeah, it is.
Okay.
It's pronounced ASCII, but it's actually American Standard Code in Information Interchange or something. Oh, the American Standard Code for Information Interchange. And way back in the old days, this is when they started this, and it only actually went up to 127. So that's just 7 bits. And all of these beginning ones here are things that you would need on a teletype machine. And so the bell, ding, 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 and the startup text, and this maps into back in the really old days. If you want a high speed, feeding in your program, you would have a paper tape, a roll of a paper tape, which is pretty heavy tape, and there's holes,
I remember.
Yeah, exactly. So
this looks familiar.
Yeah, that's exactly what. So
I just didn't know what they called it.
Yeah.
All right. Thank you.
And now there's like two. They use 2 characters or 3 characters, and there's all kinds of other stuff. But it all starts. I mean, it's all still compatible with this. So this is all. It still all starts with this. So yes, this will be here forever, and so you'll see it in assignments like this. But yeah, so it's actually built into the language, in all languages. So it's something you can count on. And the funny things is capital letters or lowercase letters come before capital letters. And if you notice here, the numbers start at the space is where below space, these are all the special characters. Like this is the carriage return, and this is the line feed, and there's tabs and so on, controlling devices and all that. And then starting at 32 or hex 20 or whatever, that's the space character. And then after that, it's 33 is the exclamation point and all these. And so these are all the things across like the top of the keyboard.
Is carriage return still used?
Yeah, what is CR is some languages you have to have both a carriage return and a line feed. Whereas with the languages we're used to, like Unix and Linux and all that, just the line, they just use the line feed. But there are some times where you'll actually get messed up if you don't include that carriage return in there, and you run into those kinds of problems, or you used to at least, when you're converting between like a Mac or a PC, or when you're FTPing your programs down, you know, using a FTP client that always assumes everything is 8 bits, and it turns out that that matters. And anyway, yeah, you still have to be aware of it. And sometimes when you just can't figure out why something, it works here, but it doesn't work over there. I just can't figure it out. Well, then look and see, and you know, count up the number of characters. And if one file is just a little bit more, that means that they probably use both character turn and line feed. And whereas the other one is a little bit smaller, because really, you know, most programs, you know, a line feed is taken as the thing, which means, you know, as kind of the delimiter of lines. Anyway, okay, that's it. Those are all good questions, and you run into that when you're dealing with strings like this, and capital letters, and so on. So here's here you're doing string comparison, and you know, this is the wait, what is it? Is it lowercase? Oh, no, lowercase, yeah, no, lowercase is bigger, that's what I meant. Lowercase is bigger than uppercase. Uppercase A starts at 65, and lowercase a starts at 97. So lowercase words are bigger than uppercase words. They're higher value. And so that's why we see here, the lowercase a is a 97, and the uppercase a is 74. So anyway. Here, you know, there's this is operator in Python, and you know, Python has got, you know, there's equality, and then there's testing whether they actually are the same object. I guess you have this comes up in object-oriented programming. So you know, just I don't know why you ever, it's not very often that you would want to know if this is exactly the same object as this. Really, you want to know if this equals this. If the value that's inside student name is this, and then you would use, as you might suspect, you use the double equal sign. If you actually want to test if it's the same object, actual object. So this has this is being stored someplace in the memory, and it's at a particular memory location, and this represents an object that's stored at a particular memory location. And if those two memory locations are the same, it means it's the same thing. Then this is true. But it's possible that student name is someplace else, and it just happens to equal this. You know, doesn't have to be the same object. Just you know, the contents has to be the same. So anyway,
I have a question about
yes.
that. Mm-hmm. So for using the double equal sign in order to find a string with a variable there, let's say the name Amy Adams was typed like Amy Adams and then with an underscore at the end. So if it's double equals, will it return the value? Because technically the string is different.
Yes, right. No, yeah, that'll be false. That'll be false. So yeah, no, it has to be exactly the same. And I kind of wasn't referring to that. Yeah, this has to be, you know, the same number of characters, 1, 2, 3, 4, 5, 6, 7, 8, 9. This has to be the same number of characters. If it has to start with a capital A, and then has to be a lowercase, you know. So student name can take on multiple values. Like, in fact, let's just take this and paste it in here.
Versus, what if you were using the is operator? Could you find that set?
Okay, so you might be thinking of the in operator. You know, the in operator is a good
Okay,
operator,
okay.
but yeah, this is. And so when I first came, I studied this, I studied these chapters, before I, you know, um, lecture to you folks. And I didn't even like really know about this is operator. And I just thought, geez, this is confusing. And there's other stuff that they don't bother to share with you. Like they haven't shared with you that, I don't think they've shared with you that you can do, uh, A comma B equals 5 comma 6. And what that does is the 5 goes into the A and the 6 goes into the B. I mean, they haven't shared with you that yet.
Yeah, no, I think you showed that to
Yeah,
us.
yes, but so why are they bothering with this, sharing with us this is operator? It's like, geez, you're only throwing that out there and you're confusing people, because I don't know when you'd ever use that. I just can't think of a case, but I'm sure there is, because otherwise they wouldn't have the feature in the language. But yeah, right. Yeah, so it's like yeah, there's membership operators, so look right up here. And then there's these identity operators. And that says like if they're actually the same object. And a common error is to use an identity operator in place of an equality operator. It's like it's only an error in Python because they bring it up too early in your teaching. But anyway, so yeah, so just don't ever, I mean, the first time we come across a case where you actually want to test using this operator, I'm gonna have to remember that, because I can't even think of one. All right, so there's some other methods too. These are methods that you use by tacking, there's these are like infix operators on strings, and these are just methods expressed in a different way, as you know. But there's this these all return true or false, and this one returns true if all the characters are alphanumeric characters. This is short for is alphanumeric. And so all the characters are either lower uppercase letters or numbers between, or digits. And so like if, and then this will return a true if all of the characters are digits. So if there's one letter in there or one space or a comma, it'll return false. If they're all exactly digits, then it'll return true. This will return true if they're all lowercase letters. If all the letters are lowercase, there can be stuff other than letters in there, and it won't look at those. And this is for uppercase. And this is true if all the characters are white space, and white space includes the character turn line feed, those tab, those other characters that produce white space. And this returns true if something starts with X, and this returns true if something ends with X, otherwise false. So anyway, that's good. And then these actually return another string. They return a new string, and it's a copy of the old string that's the argument, but done something to it. And so this will capitalize all of the characters that can be capitalized. This will make lowercase all the letters that can be made lowercase. This will, this capitalizes the first character. I guess it just capitalizes the first character. Anyway, I was going to see if there's spaces in there, if it actually capitalizes the character after space, but probably not. All right, and then this makes them all uppercase. This strips out of their spaces to the left or the right. It makes it so there's no white space around it. And then this is the one. This is titled. Titled capitalizes the first word. The first letter of every word is capitalized. That's what I was thinking. And you can kind of cascade these operators these methods. So this is going to read in an input, and then it's going to strip off the white space. It's going to do this one, and then it's going to make them all lowercase. And so name is going to be whatever they inputted without any spaces to the left or the right, because sometimes you might just inadvertently type a space after every word that you type. And so then you end up inputting something that's got a space on the end of it. And then when you're trying to match something, it doesn't match because there's a extra space on the end. And so it's nice to have a strip function built in. And almost all languages have string functions built in. And then title is nice. So anyway, that's what that does. So anyway, that's good. Find abbreviation. So let me kind of try to get through all of the sections of the chapter today, and then I'll come back after having time afterwards and maybe do some of the challenges. All right. So, but I can explain what these are. So I'll leave that one for you. Okay, so here we have it's a program where you enter in a tweet, something like this. Wait. Oh, here, something like this. And what this program does is it searches the string to see if there's an LOL in there like that. And if there is, it prints this out. Otherwise, I guess it doesn't print it out. Oh no, it just says no. It says no abbreviation. And so, this is you can do if user tweet. Oh, if LOL in user tweet. How's that? See if that works. Oh yeah, nice. Okay, this is the same thing. No, this is replacing. There's a replace function, isn't there? Yes, there is. User tweet dot replace. I don't know. Replace TTYL with talk to you later. Invalid syntax. What's invalid about it? Well, okay. What? Can I do this? All right. It's 412. Oh, splitting and joining. Okay, so there's a method that split, and what that does is it splits it into a list. And the default is it splits on a space. So the default is it takes a string, and it takes a space as a separator, and it creates a list. So this would create a list with 4 words in it: Martin Luther King and Jr. like this. So it turns it into something that looks like that. So that's split, and the default is a space, of course, so you don't have to put anything in there. But if you want it to be something else, like a comma or a hashtag, then you put that in there like that, and then it does the splitting like that. See, so that's a split function. It's very valuable. Lots of things you can split. Lots of things. Yeah, so this format statement is you're just putting the format string right there, and separator, it's one argument or parameter, and it's just that here you just use the order, and so it's going to replace what that is right there. All right, anyway, so that's split. Talks about split. Here it splits on, this is line feed, the new line character, the this one, 10, not R, that's /R, 13 is /R. Anyway, oh, and then there's join, and that's reverse. That with this you join everything back up again, and the string is the actual join character. See, so it's the separator. So here your separator is a slash, and you're going to join this with this with this, and so it joins those 3 words. It puts a separator in between, and so of course it's going to be slash whatever. It's going to come out looking like that. So so you can do it this way. If you don't use a join, if you don't use the join method as a join method of a separator, where the argument is a list to be joined up. The manual way to do it is something like this, where you for all phrases, for all phrase in phrases, or for in other words for all of the items in the list, from left to right, concatenate them on. Concatenate them. It's the same as this, where you're concatenating, just not even no character. You're just attaching all the words together. So anyway, and the argument, there's these 2 things do the same thing. The argument is this is kind of not as easy to understand as just this. Of course, you got to know what this means. But after you know what this means, then yeah, this is a simpler way of expressing. All right, so that's joining.
Is there a space in between those 2?
No, no, there's
Okay.
not. There's not even anything. So here, the space is here. The spaces are built into the strings.
Okay.
And you don't usually do them. You don't usually do them together, but okay. Here, assign number segments with phone numbers split by hyphen. Oh. All right, so this is just supposed to split Okay, so you read in phone number, and that reads in like reads this in. And then you want to pop off the first 3 characters. But you want to do the segment. Okay, so you want to do something like phone number split hyphen, I guess. Yeah. All right. It's 418. Oh, this is checking if it's an integer. The checker for integer string. Okay, so first time I did this way. I see my answer still here. This is how I would do it in any other language. I read in the input string. I read it in, and I'm going to check to see if it's all digits. May sound familiar? So this is all digits, and this is not all digits. So this should say no, and this should say yes. And so not thinking about that fancy is digits method, I wrote this. I started out by saying the default is going to be yes. In other words, I'm going to read in this thing, and I'm going to assume it's all digits. So I start from the beginning until I find a character that's not a digit. In which case I'm going to set out equal to no, and then I'm going to break out. Okay, so I have this index I. It's going to go in with the range of the length of the user string. And for each of the characters, I test if the user string is less than whatever this character 0 is, or it's greater than whatever the character 9 is. If it's either of that, in other words, if it's less than 48, because that would be something up here, or greater than the character 9, that'd be something down here. Okay, so if it falls outside of this range, then I want to set it equal to no. And in fact, I'm done because I already know, because now I know the answer, and I break out of here. And I go down here and I print whatever out was. If it makes it all the way through, and this makes it all the way through, and this never is true, in other words, it's always inside the range, then this never gets executed, in which case out is going to remain yes, and so then this would work. And so here is an example. It works correctly. And if I make it that, then it's correct. And I can submit that, and I believe I get the right answer. Oops, yes, 10 out of 10. However, you can use that is digits thing. Let's see if I have it in my notes here. Huh? I don't have it in my notes. It's is digits. This is digits. Oops. String methods. Yeah, string methods. Replace, find, count. Is digit. Returns true if all characters are numbers between 0 and 9. I'm just going to copy this dude. Copy. And go to, is that down at the bottom here? Oh, this is laughing out loud. No, it was 7.5, I thought. Something in 7.5. Oh, is that this? Is this what I was doing? Oh yeah, this is what I was. Oh yeah. Okay, so I can just if user string dot that. If that's true, then print yes. Else print no. Let's see if this works. Yes. No. Submit mode. Submit for grading. Yeah. Well, what do you know? Okay, so clever. And Python. That's clever. Is this where I am already? So I've started doing the assignment, the labs already? Okay, great. Name format. Oh, okay, with this one, you read it a name, and you're supposed to print it out like this, where it's a last name and then first initial, second initial with periods. If the person only does the first name and the last name, then it doesn't do the second one. So let's see. First, do I gotta have an input in there? Guess I gotta start from scratch. Huh? Let's see, it's 424. Let's see. Names equals input. So I'm just gonna do that. Enter. Yeah, okay. All right. So names, and then I'm gonna do full name. Full name equals that. And I'm gonna say names equals full name split, just like that. Default space. Then I'm gonna do what's the length of names? If length of names equals 2, then print out equals names 1. This will be the last name because it's only 2, so it's going to be first name, last name plus a comma and a space plus first initial, which is names 0, 0. Yeah, that should work. This is the first name, and this should be the first digit, the first character of the first name, plus period. Otherwise, I'm going to assume it's 3. This would be I'm gonna do this. I'm gonna put this here, and then I'm gonna say if it's equal to 3, then out, add on to out, space, comma, names. Oh, no, this one. This one. Okay, that's if it's 2. Otherwise, if it's equal to 3, I'm just going to assume it's equal to 3, and I'm going to do, it's got to be first name, last name 2. This 0, 1, right? Oh, I didn't get the last one. Plus names 1, 0. Okay, so and just so you can see this better, I'm going to do this. When this comes in, I'm going to say print names 0, print names 1, and print names 2. Let's see if it even works. And oh, after this is all done, I want to print out. Okay, I'm going to see what this looks like. And so I'm going to say Joe Schmo, run program. Okay, so it didn't work. So because there is no names of 2. So what if this works? Forget it. I'll just do this. What does this say? Run program. Names. All right, run program. Okay, this is name of 0, name of 1, and oh, anyway, so I printed that out correctly. I don't need to show this. But let's see if it works. The second one, Joe Samuel Schmo, run program. Names. And I don't want to do Joe Samuel Schmo. I'm going to do Joe Tiberius Schmo. Tiberius Schmo. Run the program, and it should be, oh, there's no period. Joe Tiberius Schmo. I need a period there. Plus, dun, dun, dun. Yes, run program. JT Schmo. Okay, so and what's the test one? Pat Silly Doe. Doe P. Okay, yeah, I'm sure it works. Let's see. So it looks like I got all the points. Okay, fantastic. What is the? Yeah, I didn't copy over all the solution, all the challenges. Anyway, all right. So are there any questions? Okay, so this was finishing. How far did we get? We got up to 7.6, and there's 7, 8, 9, and 10, 11. Okay, so yeah, let's do those. Let's do those next time.
Thank you.
You're welcome.
Thank you very much.
I'll get back to you, Harang. Yeah. Okay. See you.